After years of debate, scientists finally confirmed time mirrors, and the results are wild. What they found challenges some of our most basic intuitions about how waves behave. Scientists use the term time mirror to describe something really unusual. It's when a wave, like light or sound, bounces back in time instead of in space. In a regular mirror, light hits the surface and bounces back, so you see your face. But in a time mirror, the wave doesn't bounce back in space. Instead, it reverses in time, like hitting rewind on a video. The wave starts moving backward through time, as if it's undoing itself. This experiment did not reverse time itself. No clocks ran backward. No causality was broken. Instead, physicists reversed electromagnetic waves in time. That distinction matters. When this reversal happens, the wave doesn't bounce around like it normally would. Instead, it moves backward through its own path, like it's undoing everything it just did. And until now, no one had ever cleanly demonstrated this in the real world. The breakthrough came from a team led by Hady Moussa at the City University of New York Advanced Science Research Center. Their results were published, and they represent the first clear, repeatable observation of time reflection in electromagnetic waves. The key wasn't manipulating time, it was manipulating the environment the wave travels through. Normally, waves behave according to the medium they're in, but if that medium changes, suddenly, something very different happens. The researchers created a material using a metal strip and extremely fast electronic switches that allowed them to change the material's electromagnetic properties almost instantly. At exactly the right moment, they made electricity flow through the system much more slowly, and that sudden change created something extraordinary, a temporal boundary. Not a wall in space, but a boundary in time. When the electromagnetic wave encountered this temporal boundary, it split. One part continued forward normally, while the other did something no ordinary wave does. It reflected backward in time, forming a reversed copy of the original signal. This wasn't interference, it wasn't a signal echo, and it wasn't a trick of processing. It was a real, physical reversal caused by a controlled change in the system's properties, a time mirror. This is fundamentally different from normal mirrors. A regular mirror works because a wave hits a surface and bounces back in space. A time mirror works because the rules governing the wave change instantly. Nothing moves backward in space. Instead, the wave reverses in time. That's why all the switches across the metamaterial had to be triggered at the exact same moment. Even a tiny delay would blur the effect and prevent the reflection from happening. When done correctly, the reversal was clean and repeatable. The idea of time reflection has existed since the 1960s. The math predicted that a sudden, uniform change in a wave's medium could force a time-reversed response, but achieving the required precision was thought to be nearly impossible. That's what makes this experiment different. By using programmable electronics and accessible components, the team created the sharpest temporal interface ever achieved in an electromagnetic system. The result is that a long-standing theoretical prediction finally crossed into reality. Something else happened at the same time. When the wave reversed, its frequency shifted. That means this technique doesn't just reverse waves, it can move signals across the spectrum. This opens the door to spectrum engineering, adaptive filters, frequency-selective devices, and new ways to control signal flow, all without moving parts, just timing. Until now, engineers controlled waves mainly through space lenses, cavities, reflectors, and boundaries. Time mirrors add a completely new dimension. Researchers are already exploring temporal cavities, applications to acoustic, mechanical, and spin-based waves, and layered time interfaces that create entirely new interference patterns. This work connects directly to time-varying photonic media and space-time metamaterials. fields that until now lacked solid experimental proof. This experiment does not mean that time itself can be reversed, that the past can be changed, or that causality is broken. What it means is far more precise, and arguably more powerful. Scientists now have a way to engineer wave behavior in the time domain just as cleanly as they do in space. That's a new tool for physics. And once a tool exists, uses tend to follow. Researchers are now working to improve timing precision, extend the technique to higher frequencies, combine spatial and temporal boundaries, and explore time-based computing and communications. As hardware improves, entirely new system architectures may emerge, where signals are shaped not just by where they go, but when they evolve. If you genuinely enjoy exploring the universe and its mysteries, consider subscribing. It helps us keep going. For the first time, a prediction that lived only in equations has been verified in the lab. Waves can be reflected in time, not by breaking physics, but by using it more precisely than ever before. And this discovery rewrites what's possible. Do you think time-based wave control will become as important as lenses and mirrors, or will it stay a niche experiment? Tell us in the comments below, and see you in the next video.